listening. This is important and pertinent to all of you. Today we're going to finish. We only have one more thing to do today. Okay, and then we will be done, and we're going to start reviewing. Okay? Now, in your homework sheet thing, it said to do, you read your little homework sheet, it said part of the assignment was review P1 to P5. You know what I'm talking about? If you looked at your little half sheet homework thing. If you look in your packet, there is a sheet that is literally called Review P1, P5. This is the sheet that's assigned, and these are the answers to it right here, okay? This is due on Thursday. That's on the assignment sheet. Everything on the assignment sheet is due Thursday. So I'm just clarifying, make sure you're getting that done. This sheet right here, Review P1, P5, is what's on the assignment sheet, which is due Thursday. Along with that, it says Quiz P1, P5, doesn't it? In your packet, there are probably at least 6 things that are called Quiz P1, P5. And they may have something else like Period 1 is super or something written on it. Doesn't matter. If it says Quiz P1, P5, and there's a ton of them, pick one. Pick one of those and do it. Okay? So on the assignment sheet, along with the book problems, it says Review P1, P5, that's in here, and Quiz P1, P5, which is you get to pick. Just pick one. There's a ton of them in there. Do them all if you want. All right? And you will rip those pages. Well, the review sheet, you'll do that on a separate paper anyway. But the quiz you do, just rip it out of the packet and attach it to your homework. Is there any question about that? All right. Then yesterday, I posted the review work, which is due on test day, which is still set for Friday. Okay? Now, the review work is 2 parts. The chapter review in the book, selected problems, so there's a list of problems to do on the chapter review. And then there is a review sheet. That review sheet is in your thing, and it is called, literally, Chapter P Review. And the answers are provided, so that you can check. So everything on that half sheet of paper that I gave you is due on Thursday. The book review and this review sheet are due on Friday. Okay? Today we're going to start reviewing. So today we may start going through some of these things. Everybody good? Okay. So let's do the last, well, let's do 2 things. Let's do another example of the inequality that we were talking about yesterday. Quickly. In fact, you know what? Let's do an example of all the kinds of inequalities just to make sure that we are settled on that. So we have this kind. Now, I don't care how you do this, but I will always do it with a number line. Every one of my inequalities, I sketch on a number line. You don't have to do that, but you have to have the way it works. Obviously, we want to get the right answer. Robbie, did you have a pass?
No, Sam.
Okay, you need to go up to the front office and check in with Mrs. Sam. Do you know how that works? Okay.
I'll just go up there.
Okay, you know where the front office is, yeah. Just tell them you were late and need them. Okay. So, right in the middle of the number line goes -5. And then I'm simply going to count back and forth 6. So that would put me at 1 and -11. Right? These are review problems now. I'll put solid dots. And then I figure out where to shade. My options are between the dots, outside the dots. Since it's a greater than, it's going to be outside. Now, I want to talk about something here real quick. You know how in the other inequality type problems I've done, I put the dots on there, and then I've had you check spaces, and then we said they alternated, you know what I'm talking about? Okay, could we do that with this problem? Absolutely. Once you get your two dots on there, you know it's either going to be shaded here or it's not, right? So you could pick a number and put it in and see if it works. With these guys, if it's a greater than, it's always outside. If it's a less than, it's always inside. So we don't usually mess around checking a point, but if you were unsure, you could always do that. So our answer is negative infinity to negative 11 bracket, or 1 to infinity. If the directions don't say write as an interval, then you are welcome to write it as an interval, or you're welcome to write it like this. But you must write an answer. The picture isn't enough. That's your work. You have to write an answer, either this way or this way. Okay? All right. So we have that kind of inequality. Yeah?
Can you set that equal, do another one like x plus 5 is greater than or equal to 6, and then another one x plus 5 is greater than or equal to negative 6?
It would be less than or equal to negative 6, and that will always work. Okay? It's not going to help you one iota in calculus class. That's why I kind of want you to get used to this, but that will give you the right answer every time if you set it up right. All right, let's try this one now. How about x squared minus 5x plus 4 less than 0. This is a polynomial inequality, specifically a quadratic inequality. So what is our strategy with these guys? We factor x minus 1 minus 4. Then we draw our handy-dandy number line that we just love drawing. And we're going to put two dots on the number line. Ferguson, where are they going to be? 4 and 1. And we're making sure we're putting them on there in order, right? 4 and 1, we got to get them in order on the number line. Thank you.
Thank you.
And then we will pick a point anywhere you want. There's nothing funky about this problem. So I know they're going to alternate, shaded, not shaded, shaded, not shaded. But I just got to figure out which is which. So I can pick any point I want. What point do you want to pick?
0.
0. That's the easiest one. We love 0. Just pay attention. 0's over here this time, right? So I'm checking this region right here. When I put 0 in, aren't both parentheses negative? You can work it out if you want. I just care about positive and negative. They're both negative. So what happens when you multiply two negatives? You don't get what you want, because what you want is less than 0 in this problem, right? So this didn't work. So that's not shaded, which means this is, and this isn't. So my answer is all of the numbers in between 1 and 4. Patty, is that making sense to you?
Yeah, it does.
Okay.
Do we need to know if we do it like both ways, or can we just put it in interval?
Interval is fine.
Yeah.
Now, the kind that we finished class yesterday with a problem that is a rational inequality. So let's practice one of those. We only did one, so I want to make sure we, at least do another one here. Does anyone remember from yesterday how we start this?
Get 0 on one side.
Patty? Get 0. We've got to have 0 because when we're doing inequalities, we like to know whether we're greater than 0 or less than 0. This means I'm looking for negative, right? Less than 0. Okay, what do I do next? Do you remember? Get a common denominator. You're going to make one big giant fraction out of this. Now, this is not a complicated step. You've done common denominators since you were little. So we'll multiply the top and the bottom by x minus 3. Now our denominator is x minus 3. So 2x plus 1. All right, now be careful. This is going to be what? Minus 3x plus 9. Which simplifies to, I'll put it, let's see, I'll come over here. So that simplifies to negative x plus 10
Yep, over x minus 3.
over x minus 3 less than or equal to 0. Once I get it one big giant simplified fraction, I'm ready to put the dots on the number line. Now, the bottom dot is pretty obvious. It's going to be at 3. Now, the top one, I need you to be careful with. If you put 3 in here, you get 0. What do you put in here to get 0? 10. Positive 10. Positive 10. If you put 10 in there, isn't that 0? And that's what you put here, is the number that makes it 0. So if there's confusion, just over to the side, say, okay, what will make that 0? And when you solve it, you see that it is 10. When we put these negatives are almost always in these problems. Almost always that's going to be negative. So you really, really need to be careful and get that dot in the right spot. Now, tell me about those dots. Are they open or closed?
10 is closed.
10 is closed. Somebody was listening yesterday. Why is 3 not closed?
You can't have 0 on the
Because you can't have 0 in the denominator. Think of our Mathlete t-shirts. You can't have 0 in the denominator. Which we're all going to buy, by the way. Okay. Now what do? We got our dots on the number line. Now what? Now we pick a number, and again, you can pick any number you want. There's nothing funky about this. It's going to alternate. So I don't know, you want to pick 0 again? And again, 0's over here. So if I put 0 in, my top would be positive and my bottom would be negative. If I put a positive over a negative, do I get what I want? Yes. This means negative. Less than 0 means negative, right? So this works, which means this works. So my answer is everything from negative infinity to 3, or 10 to infinity, and there's a bracket on that 10. Or if you prefer, x is less than 3, or x is greater than or equal to 10. Alright, now, I want you to try one with your partner. And then we have one more thing to talk about, and then we'll start reviewing, okay? Although all this was kind of review, but let's do one more with our partner. Let's try 3x plus 1 over x minus 4 is greater than, let's say, 5. Okay, so go ahead and work on it with your partner there. See if you can get this figured out. I'll do it also on the board. Yeah.
What? It's getting better. Okay. The shot. What's the HP shot? I can't see it. You can't see it.
So once you find that, your vote is going to be so many, that'd be like, and then you find out how many. Once you read that,
You just set it equal to 0 and the separate number is x minus
4. Before I go any farther, you matching up to this point? Is this the big fraction you got? Okay, were you careful with your dots? All right. Both of them are open this time.
oh, yeah.
Are they both open?
Yep, they sure are. I got dots at 4 and 21 halves. Anybody else get dots there?
It's not, it's just.
Now again, if you are messing up the sign of that numerator, the SIGN of that numerator, do the work over to the side. To find where to put the dots, set it equal to 0 and solve. Because it's a greater than problem. There's no or equal to in it, right? So it's never coming in.
Fill in like, okay.
Oh, yeah.
Hey.
Did you get shaded in between?
When we pass it,
So when I put that question on the test, everybody's gonna get it right?
Yeah.
Yep. Wait, are you gonna put the exact one?
I can't remember anything. There's no way I'm gonna remember that question.
But you have it on recording.
Yeah, I can go back and watch my own
Wait,
video.
why are you recording this? Out of curiosity.
Because some people miss days.
They miss days, or they want to see it again, or I go too fast and they want to slow down. It's supposed to be, honey, it's posted on my website. Every day.
Every day there's a video.
Every day there's a video.
Where have you been setting that up?
Well, I don't take this period every day. I am today because it's a long period. I'm going to get a lot in. But
I was just like,
I guess maybe I never told you.
I want to get on screen.
You can get on my website, not Schoology, on my website, and every day there will be a video posted. Now, it may or may not be your class period, and the video that's posted for you guys today is going to, a lot of it's going to overlap what was posted yesterday for some other period. But between all the videos, you should be able to go in and see everything again. So if I go too fast, or you're not sure about something, you forget how to do something, you can go back and watch the video. If you're ever absent, you absolutely got to watch the video, right? Okay. Now, the last thing we have to talk about, and then we'll be done, is projectile motion. So I need you to open up your books to page 64, and I'm going to do your last two homework problems for you. These are projectile motion problems. Page 64, and we are looking at problem number 33. 64, number 33. Now, what we mean by projectile motion is, think about standing here and throwing a ball up into the air. You're throwing a projectile up into the air, it's going to go up and it's going to come back down. It also applies to, think about going to the balcony in the Walsh Activity Center and standing on the balcony and dropping something off the balcony. That's also projectile motion. It's a little bit different because you're not actually throwing it up into the air, but you're dropping it. There is a formula for projectile motion from physics that you do not have to memorize, but we have to use it to do these problems. I will give you the formula. You do not have to memorize it. Although after we've done a couple problems, you'll probably have it memorized. The formula looks like this. Now we're going to talk about what all these letters mean. Anytime you write a formula, especially in physics, it looks so hard, but it's really simple. It's really simple. This formula gives the height at time t. The height of an object at time t. So this is the height. Now I know it looks like two variables, but it's not. That's function notation. And you have learned that f of x is the same as y. So this is like y. That's the height. Equals negative 16t squared, and t is the time, usually in seconds. So if we wanted to know how high the object was after 1 second, let's say we threw it up in the air, and we want to know how high it is after 1 second, we would just put in 1 for the t's. Does that make sense to you? V sub naught, and that's how we read that, is V sub naught, or V sub 0, is the initial velocity of the object. So if I'm throwing it up in the air, it just depends how strong I am, what that initial velocity is going to be. What about if I'm standing on the balcony, though, and I drop it? What's the initial velocity if I drop it?
Like where you
If I just, now the initial velocity, not the height, the initial velocity. If I just drop it, how fast is it moving at that moment of drop? I mean, yeah, 0. Initial velocity is 0 if I drop it. Now, if I throw it, I'm putting some force behind it. That's going to give me a number. Okay? H sub naught. Now, what do you think that stands for? If V sub naught is initial velocity, H sub naught is initial height. So for every problem, you'll need to plug in an initial velocity, which you'll be given, unless it's dropped, and you're supposed to know then that the initial velocity is 0, and you'll be given an initial height. Now, if we are at ground level, what is our initial height? 0. If we are on the balcony, our initial height is 20, or however tall the balcony is, right? Okay, so read question 33. A projectile is launched straight up from ground level with an initial velocity of 256 feet per second. What is going to be the equation for this particular problem? There's your formula. Plug in some numbers now. What's it going to be? Negative 16t squared. That doesn't change unless you're in meters. Then there's a different coefficient, but we're in feet, so we'll leave it negative 16t squared plus 256t. Does everybody understand why she put the 256 there? Initial velocity. Okay, plus 0. Why is it a plus 0 on the end?
It's at ground.
Ground level. If you're at ground level, your height is 0. Everybody got it? So this is the equation for this particular problem. All right, so what are the questions? When will the projectile's height above ground be 768 feet? When will the height be 768? Now, notice in this equation, there are two variables. There's height and there's time. They gave you 768. Is that a height or is that a time? So that goes here. So 768, and again, I know the function notation may be confusing you. Think of this as a single variable. It's y, it's h, it's height. So 768 equals negative 16t squared plus 256t. What kind of an equation is that? Quadratic. Oh my gosh. Quadratics. How do we solve quadratics? We either factor it, complete the square, or use the quadratic formula. You have a plethora of options. Well, first of all, I better get it set equal to 0, so I'll do that. And I wonder, I know that's divisible by 16. Is that number divisible by 16? Would somebody check that on your calculator?
Yeah.
It is. So I'm going to divide by negative 16. Get rid of that guy. Now I'm dividing here. And what is it when I divide
48.
48? Yeah, that's a much more manageable equation. Could I have solved it in this form? Absolutely, but imagine what a mess that is. So here we go. Now, does that by any chance factor? 12 and 4. Now, if you don't see that it factors, or you don't want to mess around with factoring it, you could use your quadratic formula, or complete the square. This would be an easy one to complete the square on. I say it's easy to complete the square. Why? Because that number is even, so when I take half of it and square, I won't have any fractions. But now something weird is going on here, because the question was, when will the object be 768 feet above the ground? And I got 2 answers.
Plug it in.
It's on the way up here.
Oh, who said that? Good job, Ferguson. He says, look, Mrs. Ford, you are projecting an object up into the sky. What is eventually going to happen?
Down.
It's going to turn around and come back down. A quadratic equation is a parabola. It had a negative 16 on it, so that means it opens down. Here is the height. Here is the time. Here is 768. When does it hit 768? Right there. Oh, and like Ferguson said, right there. So it is hitting when x is 4 and when x is 12. Does that make sense to you? Now, next question. When will the projectile's height above ground be at least 768? At least 768. Look at the picture. When is it going to be at least 768? Isn't it right here? So what times is that?
Between 4 and 12 seconds.
Between 4 and 12. Now, here's my question for you. Am I going to say this? Or am I going to say this? Now, you've got to read the question. That's a picky question. You got to read it grammatically. What does it say? At least. Does that mean the 4 and the 12 are included?
Yes.
Yes. So this would be the correct answer. Now, what if it said more than 768? Then it would be this one, right? And then finally, when will the projectile's height above the ground be less than or equal to 768? Where's the height less than or equal to? Would you say here and here? Now, what we've been doing on our number line is saying something like this. Negative infinity to 4 or 12 to positive infinity. Okay, now wait, that doesn't work in this case. Because look at your picture. It's this section right here, right? That doesn't go to negative infinity. Time can't be negative infinity. So where does this actually start? Not negative infinity, but 0. Does that make sense to everybody? And whatever it was I threw doesn't keep moving forever. It doesn't just keep going and going. It stops because it hits the ground again, right? Any idea where it hits the ground there? Well, the height would be 0. What's the t value here? Like that one's 12, that one's 4. What's that t value there? This one's 0. Oh, 16. Where did that come from? What?
You add 4
Why did you add 4?
because it's 0 and then it's 4, so then it's 4 over.
And parabolas have this wonderful characteristic called symmetry. So it's balanced on both sides. So if it took it 4 seconds to get up here, it's going to take it 4 seconds to get back down. Now, I want you to read the problem and tell me if these should be parentheses or brackets. This is 33C. When will the projectile's height above ground be less than or equal to? They need to be brackets. All right, one more. I assigned 33 and 34. I'm doing homework for you right now. Number 34, here we go. Same problem, so we're going to use the same formula, but we're going to have a different equation because they gave us some different numbers. So, here we go. What is the equation for problem 32? H of t equals negative 16t squared plus what? Problem 34.
272.
272t plus what? 0. Why 0?
Ground level.
We're starting on ground level. Question. When will the height above ground be 960? All right, what do you do? 960 goes in where? Right here, so for the height. Move it over, so because we've got a quadratic equation, and we're going to have to solve it, so we'll get it set equal to 0, and then figure out what we're going to do with it. Are these by any chance divisible by negative 16?
Yes.
They are?
Yep.
Life is good. So if we divide through by negative 16, we'll get t squared minus 17t plus 60?
Yes.
Now this one wouldn't be so good to complete the square on, but we could use the quadratic formula if it doesn't factor. Does it by any chance factor?
Yes.
How?
5 and 12.
Minus 12 minus 5? Yep. Good. Again, if you are not very good at factoring, you're not comfortable factoring, don't want to factor, we will use the quadratic formula. Patty? Sweet pea, am I going to have to confiscate it? I need you paying attention, we have a test coming up, okay?
I did negative 20 and positive 3. Would that work?
No, because negative 20 and positive 3 won't give you a positive 60. That would work if it were a negative 60. Okay, so what do we got? T equals 5 and 12. What do those two numbers represent? In terms of this situation, those two numbers represent what? The seconds when the thing is exactly 960 feet above the ground? So in terms of our little parabola picture, here's 960, and this is 5, and this is 12. They're supposed to be lined up.
Miss Ford,
Mm-hmm.
I used -2 and -15. Oh, that's 30. My bad. Sorry.
Okay, next question. When will the height above the ground be more than 960? Now pay attention to the vocabulary. More than 960. When is that? That would be this part right here. So it would be 5 and 12. And then are you going to use brackets or parentheses? Parentheses. Because it says more than. Not at least, not greater than or equal to, it says more than. When will a projectile's height above ground be less than or equal to 960? Less than or equal to will be this spot right here. Parentheses or brackets? Brackets. So 0 to 5. Or, we have the same thing we had a minute ago. I gotta figure out what that end point is. 17, so we'll say 12 to 17. You okay? Now, I want to emphasize one more time. This is the formula. I'm going to give you the formula. You don't have to memorize it. But this is the initial velocity. That can be 0. If an object is dropped, that will be 0. This can be 0. Clearly, we've had examples of that. That's 0 when you are launching from ground level. Think of the fireworks that are launched from ground level. If you are standing on a building and you throw something up into the air, then that would not be 0. That would be however tall the building is.
So if you have it, like if you have no initial velocity, does that mean that like since you just drop it straight down, does that mean that you have 2 answers or like?
Now think about that for a minute. Think about the question that was asked is, when will the object be this high above the ground? If you drop it, let's say here's 960. And you're dropping it, how many times is it above 9, or how many times is it at 960 if you drop it? Just once. Now, you may get another answer because this is going to be quadratic. It's going to produce 2 answers, but one of them will be negative.
Okay.
And you will throw it out because T stands for what again? Time. And you don't want a negative answer. So that will happen. Okay, all right, now it's time to review. So, why don't we look at the review sheet, Chapter P review in your packet, and we'll just go ahead and get started on this quickly. And we'll have you, we'll just get our sheet of paper, and this can be your homework. I mean, this can be the start of getting your homework done. All right. Now, there are a couple things I want to specifically review with you. So we'll be skipping around. It doesn't matter on your homework. The point is you're going to do every problem. The order we do them doesn't matter. So don't get freaked out. I know some of you like to have everything neat and orderly, and I do too, and that's okay. But I really think there are a couple sections we need to talk about. Okay? Most of it I think you're fine on, but we need to talk about. So, number 1, let's get these properties right. By the way, who wrote the review sheet? I did. Who's going to write your test? I am. So would this be a good thing to know everything on?
Yes.
Yes, indeed. I did not write the textbook. They asked things that maybe I wouldn't ask. Good stuff, good to know, but I might not ask it. This is the stuff I'm going to ask. So we're going to know this. Properties, right off the bat. What's A? Please do this on a separate sheet of paper. You're going to turn it in to me. And I don't want it all packed. We can't possibly do it on here. So get out a separate sheet of notebook paper and put it on there. 1A. That is the additive inverse, or inverse of addition. Somehow in your answer, you have to have the word inverse and some indication of addition. So, inverse plus sign, add inverse. I don't care, but you have to have both of those things. All right, what about B? What's B? Commutative of addition. Commutative of addition. And again, you gotta have the two words. You gotta have commutative, you can abbreviate it, and you gotta have addition. You can use a plus sign if you want. C, cheating, didn't ask you to know that one before. Anybody know what it is? I won't put this on your test. Anybody know what it is? Reflexive. Reflexive. Remember that from geometry? Same thing with D. I won't put this on your test. It's not one of the ones we talked about. What is the property there? Remember from geometry? What goes with reflexive? Well, this isn't transitive. This is the other one. There's three of them. Symmetric. This is the symmetric property. The symmetric property says that you can flip across the equals.
You said symmetric?
Symmetric. Mm-hmm. And what's E? E you do need to know. E is, it's a trick one. It's another commutative. Why is it commutative? We didn't change the parentheses, we changed the order. We didn't do anything, the grouping, the things are still grouped the same, we just changed the order. So E is commutative of addition. Trick question. All right, now turn it over. Now, solve graphically. Now, here's how this works. Here's what you need to fill in. Remember, you're going to be sitting there at your desk, and you're going to do this entire problem on your calculator. You aren't going to show me any work. You're doing the whole thing on your calculator. So what am I going to grade? Because you're doing it on your calculator. Well, you are going to tell me what window you used. So that's what goes in where it says X and Y. You're going to put your window in there. And what do you think goes in the first little space? This will be your X min. And this will be your X max. And then the same thing for the Y's, right? Y min, Y max. Now, how many possible answers are there for these blanks? Infinitely many. And in fact, I'm not even, you're going to get, if you fill those in with something reasonable, you're going to get automatic credit. I'm not going to worry about it. It has to match, though, the picture that you draw for me. In that box, you're going to reproduce your picture. So maybe your picture looks like this. We're going to do this problem in a minute. We'll sketch it in. But you're going to put your picture in there. So you're going to tell me how you set up your calculator, what you saw when you set it up that way, and then you're going to tell me what the answers are. Okay? So let's go through this one. We're going to solve it graphically. All right, so I'm going to take out my calculator. And I have no idea how my window is set. I'm not even going to worry about it. I'm going to put in my equation. Everybody remember how to put in x cubed? Okay. If you don't, lean over and ask your neighbor. Now my window works. I haven't even checked yet to see what it is, but it works. When I say it works, I mean I can see what? I can see the curve crossing the x-axis in 3 places. And x cubed is going to cross the x-axis in up to 3 places. It may cross in less, but it could cross in 3 places. So I don't know what your window is. It can be whatever it is. Here is what I see on my screen. I see this. And I'm not real picky about how you draw it, but this is what I see. Now I'm going to tell you what my window is. My window is -6 to 4. I don't have any idea how it got this way, and -10 to 5. Now, that is as random a window as you could get, but it happens to work for this problem. If you pressed graph and you see these 3 points, your window is fine. Write it down. You do not have to write this. This is a totally random window. I could do this problem 50 times and I would never have that window again. But it works, right? So everybody's got a window that works. Not necessarily mine, but you got one that works. And you got a picture that looks something like this. Now, I don't see the top or the bottom of my hills and valleys. Not an issue to me. If you want to see the top and bottom, that's great. Adjust this and it'll work. But I'm not looking for the maximum and the minimum. I'm looking for these guys, right? So as long as I see these guys, I'm good. Now we're going to find them. So do you remember how to do that? One at a time, second count. You guys do this one. In the middle, do this one. Over here, you guys do this one. Second count. Remember, if you're on your own, you have to do it 3 separate times. Each time, starting with second count. And choose the 0 option. If you don't see your cursor right off the bat, just keep moving your arrow keys. It'll come into the picture sooner or later. I did the middle one, and I got 0.2679. So there on the answer blank, I'll put this.
So you want us to do 4 significant figures after?
Oh no, whatever the directions say, I just wrote all that down because I had it. You guys over there get one? Actually -2? What'd you guys get?
3.73.
3.73. Now, if you're a little shaky on that procedure, then go ahead and go back on your own. These are supposed to be the answers on your own. See if you can come up with those. I don't want to take any more class time on that particular problem. Are we good with it? And I'm going to say one more time. If you waste a bunch of time messing around with these numbers, I will smack you. Don't waste time on these numbers, okay? Get a picture that shows you the zeros, and then whatever you have is good. All right, now the next one. Solve graphically. Now, we know how to solve this algebraically. We just did one at the very beginning of the period. But solve graphically. Let's talk about that.
This is for.
Yep.
So we just write the answer that we got for these onto the paper that we're turning in? Just the answers?
No, you have this written down, you have a picture written down, and you have the answers
But what
written down.
about, for the separate sheet, you want us to put that?
All this goes on there. That's the answer to the question, right?
Okay.
All right, now, if you are doing this algebraically or graphically, and algebraically I mean like we did at the beginning of the period, you gotta start by getting a 0. Oops. Now, if we were doing it by hand, algebraically, what would we do at this point? Factor it. And that kind of problem is back in part 5 on the review sheet. This says solve graphically, just like you did this one. Okay? Now the only difference in these two problems is this has a greater than symbol instead of a plain equals. But like every other time, all that changes is we're going to do some shading when we're done. Let's pretend it's an equals, and let's graph it on our calculator. So what are our x min and max? And what are our y min and max? And what's it look like? And then I'll come up with my answer. So I'm not going to change a thing. I'm going to leave my window exactly as it is. And I'm just going to put in this new equation, which is x squared minus 4x minus 12. Now, I left my window exactly as it was, and all I see on my screen is something that looks like this. Now, what does that tell me? I need it bigger, because an x squared is supposed to be a parabola, and at some point it has to turn around and come back up, right? So I'm going to change my window. I think the -6 is fine, but I'm going to make that, I'm going to say 10. Now it works. I didn't change my y's at all, and now my graph looks like this. Now, I don't see the bottom of my parabola, but it doesn't matter. If you want to see the bottom, go ahead and change it again, but you don't need to. This shows me the 2 points that I need. Okay. Betsy, you got the first one already? Would the rest of you get the second one for me?
-2.
Oh, we already got them. So for an answer, over here we just said, okay, so my points are da-da-da-da-da. But this is a greater than 0. This is a greater than. So what do you think the answers are? Graphically, what would the answer be? This and this? Aren't those the places that have y values greater than 0? So what are those x values? Where does it start? -infinity to -2? They were actually closed up. Or what? 6 to infinity. When we do an inequality graphically, we do it the same as an equation. We just shade. If it's greater than 0, we shade above. If it's less than 0, we shade below.
So for the answer, we write that's only for a parabola? Or like when we're graphing?
Any inequality
Okay.
is going to come out with an answer like, this type of answer. An equation will just get plain numbers. But any inequality is going to have some kind of interval as an answer, if it's solvable. Everybody good? Yep.
Okay, so can you look at it on just the x-axis?
Yep.
Okay, so you don't have to.
Well, when we're solving graphically, this is what's on our screen, so we need to consider the whole picture. But ultimately, the answer is yes, the x's are the answer. And if we did this problem by hand, like we did at the beginning of the period, by factoring and all that, we would be looking at the x-axis.
Okay, and so if the sign is flipped, it would be in the middle?
Yep.
Okay.
Because less than 0 means negative, and these are negative y's.
Okay, that makes sense.
All right, number 10. Yep. Is it an emergency? All right. Number 10. Now, when I first look at this problem, my gut instinct is, oh gosh, I'm going to have to go to stat and put all this data in. But read the question, kids. What does it say? Using the data for Buffalo and Houston. So what are they doing? They're picking out 2 points and saying, write the equation of the linear function. Okay? Now what does that mean? Write the equation of the linear function. Write the equation of the line. So what 2 points are they giving me? Buffalo is 400, 118. And Houston is 1600, 298. And we're going to write the equation. All right, so here we go. Slope. 298 minus 118 over 1600 minus 400. I just do not feel up to that arithmetic. So I'm going to use my calculator. I know a real teacher would do this, but you're stuck with what you got. .15. Everybody okay with that? Are you all right? So that's my slope. Now what do I do? Pick a point, and you can either use point slope or you can use y equals mx plus b slope intercept. Doesn't make any difference. Do whatever is easiest for you. Pick a point. 118 equals 0.15, 400 plus b. And again, I'm going to rely on my calculator. I got b as 58. Anybody match that? Yep. So my line is 0.15x plus 58. So that is the answer to question A. Remember, when we set our ordered pairs up here, we set them up as distance, comma, cost. Correct? So in our equation, the x's stand for distance and the y's stand for cost, the way we set the problem up. So when it says it costs $172 to fly to Indianapolis, the 172 is going to go in for y, because it is a cost. So 172 equals 0.15x plus 58. Does everybody understand why the 172 is here?
Yeah.
So then, again, relying on my calculator. Yep.
If we were getting the x, we would just plug it into the x and find the y.
Yep. Yep. So what am I doing? Subtracting 58 and dividing by 0.15. I got 760. And the unit on that 760 would be what? Miles. Although I never specified that in the problem, didn't I? Did I? We're going to say miles. And finally, number 11. This is what we just talked about. A ball is thrown upward with an initial velocity of 30 feet per second. Oh, and it's starting at a height 6 feet above the ground. Okay? So it's like, aren't you a baseball player? Yeah. Okay, so it's like the baseball player here that's 6 feet tall, and he's throwing the ball up into the ground. So it's starting 6 feet above the ground, and up it goes. All right, so we got the formula. Now, do not be alarmed that this over here says S of t. Physics people love to use S for distance. I prefer to use H for height, or if I'm really feeling like not so intense, I'll just use Y. Because that's what it is. It's another variable that stands for height. S of t, H of t, P of t, I don't care what you want to call it, it's just another variable. And now I gotta put some numbers in here. So for my equation, this will always be negative 16t squared. What goes here? 30t. What goes here? 6. Write the equation for the height of this particular ball at time t. Right there it is. There's the equation. That's the equation we're going to use. That's the answer to part A. That's the equation for this ball. Find the height of the ball at 1 second. We'll just let t be 1. Let me say this again, you guys. This equation has 2 variables in it. It has height and it has time. They're going to give you one of those, and you're going to find the other one in every problem. In this case, they gave you a time of 1. Okay, so the height will be negative 16 plus 30 plus 6, which is 20 feet. When is the ball on the ground? Now remember, this board just told you, this equation has 2 variables. They're going to have to give you one of them so you can solve for the other one. The ball is on the ground. What does that tell you? The height is 0. So you're going to put 0 in for the height, and you're going to solve this equation. Now, this one's not going to be as easy as the ones in your book. It's a quadratic equation. Let's shrink it as much as we can. Let's divide everything by negative 2, because that's all we can do without getting fractions, and I really don't want fractions. So I'll divide by negative 2. Does that look okay to everybody? And I don't know if that factors. I don't have the energy to try to figure it out. So I'm just going to use the quadratic formula. So that will be what? T equals negative b plus or minus b squared minus 4ac. Watch your negatives now, all over 2a. So I got the square root of 321 under there. I'm trying to hurry to get this done. Is everybody with me okay? So I'm going to get 2 answers, and I'm going to go ahead and type them in on my calculator. 15 plus root 321 over 16, and 15 minus root 321 over 16. So I'll go ahead and type those in. Draw a little visual of this. this is what this one looks like. Does everybody understand that? Because it started 6 feet high. We had to figure out when it was on the ground. Reality is, it's only on the ground once. Mathematically, it's on the ground twice. But that one doesn't make any sense because in that one, t is negative, and we don't want a negative t, but you understand why that happened, right? And why we would throw it out in this case. And the last one, when is the ball higher than 10 feet? Okay, so remember it got released at 6 feet. So here's 10 feet. When it's higher would be this right here, right? What do I need to figure out in order to answer this question? Don't I need to figure out when the height is 10 feet?
Yeah.
So how will I do that with my equation, which is right here? I want the height to be 10 feet. So I will have 10 equals negative 16t squared plus 30t plus 6. Everybody okay with that? Remember, there's two variables. You're going to have one of them given. You just got to plug it in the right spot. So we're going to put a 10 in there. So 0 equals negative 16t squared plus 30t minus 4. I'll do what I did before. I'll divide by negative 2. And then what? Somehow solve it. I don't think it factors. So I'll use my quadratic again. This time I got 161 under there. Did anybody else? All right, how many answers is this? 2, and hopefully they're both positive because I'm looking for one here and here, right? So here we go. 15 plus 8 divided by 16. I got 1.73. Oh wait, that would be over here. And then 0.14. Anybody match those?
Mrs. Ford, you can't solve that by factoring?
I don't think so.
Because I did 8t plus 1 times t minus 2.
Okay, but if you do a plus and a minus, you won't get a positive 2.
Oh, okay.
Remember, if that's a positive, they have to, in this case, they would have to both be negative.
Okay.
If it solves by factoring, absolutely you can. When I get answers like this, I know it didn't factor.
Okay.
So, wait, what's the answer to the question? When is the ball higher than 10 feet? In between 0.14 and 1.73. Brackets or parentheses? Parentheses, more than 10 feet. We have class tomorrow, so, but we do not have class on Thursday, which is when it's due. So Friday, so we have class tomorrow, but that's your last time in class to ask questions. Okay, now you can still come in on your own and ask me questions. If you have your homework all done tomorrow and you want to turn it in, I may be inclined to give a bonus point for early homework. It is due Thursday, so you will have to find a time during the day Thursday before 3:05. Before 3:05 on Thursday to get that homework turned in. Okay? You guys guys before and after school. I mean, I'm in and out a couple of periods a day, but I have to teach as a department chair. I have National Honor Society stuff. All right.